kids, Miss Kulkarni here. In this video, we will continue with organic chemistry, and in fact, we will learn about some general naming rules. But before that, let's revisit the different categories, different types of hydrocarbons. So, based upon the type of carbon-carbon bond, we classify the compounds in different categories. So we can have a single bond, double bond, or triple bond. Also the compounds could be chain or it could be ring type. So we got alkanes, which is all single bonds, alkenes, which is double bond. Then we got alkynes, which is triple bond. We got cyclic compounds, which are ring form, and we got aromatic compounds which have benzene ring. So what are alkanes? These are hydrocarbons which only have carbon-carbon single bonds, no double bond or no triple bond. Then all of these compounds, when we name, they will end up with ane. Then the four bonds are formed with carbon and they all are single bonds. And how can they get connected? By a process which we call as catenation process. Now where do we begin in this naming process? The very first thing is we need to count number of carbon atoms. And it's extremely simple how the name is connected with those number of carbon atoms. For first four numbers, there is a phrase which I'm going to explain to you, and for remaining one, they match with simple mathematics. Here are the first four saturated, unbranched or cyclic hydrocarbons. They are methane, ethane, propane and butane. And I'm going to tell you a phrase, Mom eats peanut butter. So what the phrase has to do? There is Mom, there is M, the number of carbon atoms is 1 and the name is methane. Next one is eats, there is E, number of carbon atoms goes to 2 and it's called ethane. Peanut, that goes to 3 carbon atom numbers and the name is propane. And then we got butter, that's B, the number of carbon atoms is 4 and that is butane. So there itself we got methane, ethane, propane and butane. That's the order of alkanes with carbon atom number 1, 2, 3 and 4. The remaining ones are simple. The number 5 always correlates to penta, so it will be pentane. Number 6 will be hexa, so we call it hexane. We just add anes to the end. For 7, there are 2 possible names. Hepta is more common, but there is always septa used sometimes. So it will be heptane or could be septane. Number 8, for carbon atoms, it will be octa, like octopus, so it will be octane. 9 always stands for nona, so it will be nonane. And for 10, it will be deca, so it will be decane. So basically, if you know the number of carbon atoms, you can easily get the root name and add ane to it, and there we go. We got the name of the basic alkane. One of the simplest way to write condensed formula when there are no bonds shown up and we just put CH3, CH2, CH2 and so on. The next one is a line drawing. We simply draw the lines and we of course have to imagine there is carbon at every junction and the required number of hydrogen. Then there is the structure where we show all the bonds. That's called cacule structure, where each carbon will have 4 bonds. Then there is a ball and stick model. When we actually construct the models, this is what it looks like. So this is a 3D model. And then there's a perspective formula. Instead of having those balls and sticks, if we imagine having hydrogen atoms in space. So let's look at the molecular formula for all these alkanes. Mom eats peanut butter. So it's methane, ethane, propane, butane, and of course, next one comes as pentane. If you look carefully with the molecular formula, every single alkane has extra carbon atom. And then the hydrogen atoms is linked to number of carbon atoms. In fact, from methane to ethane, we add CH2 and we get correct molecular formula. From ethane to propane, again if we add CH2, we get next one, and so on. So each of the alkane differs from subsequent alkane by a group CH2. Also, how about the general formula? You can figure out if number of carbon atoms is N, hydrogen is 2N plus 2. So let's maybe see if it is C equal to 5. How do you find out hydrogen? It is 2 times N, which is 2 times 5, 10, plus 2, that will be 12. And is that what we got? Yes. So what do you think? Was it easy? Let's move on to naming alkenes now. And we are going to talk about acyclic alkenes, that means straight chain alkenes. Now alkenes always have at least one double bond, so we refer to them as unsaturated hydrocarbon. Look at the names. If you get the number of carbon atoms 2, we call them as ethane. Mom eats peanut butter, so 2 stands for ethane. Number of carbon atoms 3, it's peanut, so that's propene. 4 becomes butter, so it is butene. 5 becomes penta, so it's pentene. 6 becomes hexa, and it will be double bond, so it's hexene. It is extremely straightforward to get the name of the alkene as long as we find number of carbon atoms. How do we draw the structure formula? This is the line diagram where each of the junction actually corresponds to carbon. We don't have to write down that carbon, it's understood. Or this is the ball and stick formula. So now you know how to name the chain for alkanes and alkenes. Why not talk about alkynes? Alkynes are the unsaturated hydrocarbon. We call it unsaturated because they will have at least one triple bond. And then the molecular formula, of course, for this becomes C2H2, which is ethyne or acetylene. It's extremely simple. We get 2 carbon atoms. So using our phrase, Mom eats peanut butter, it corresponds to eats, which is eth. And since we have a triple bond, the compound is ethyne, or we also have a common name called as acetylene. So here's the deal. If I know the number of carbon atoms, that means if we know the number of carbon atoms, we can easily predict the name of the parent chain for alkane, alkene, or alkyne. Let's look at this table. If we have one carbon atom, that's mom, so corresponds to meth, the alkane is called as methane. We don't have any alkene or alkyne possible with one carbon atom. If it is 2 carbon atom numbers, the suffix for that is eth. We get ethane as the alkane, ethene or ethylene as the alkene, and we get alkyne as ethyne. If we have 3 carbon atoms, we get prop, so it is propane. For alkene it will be propene, and it will be propyne for alkyne. What about bute? That corresponds for 4 carbon atom numbers. So alkane will be called as butane, alkene will be called as butene, and alkyne will be called as butyne. The last one on this chart is 5, so that is penta. The alkane will be called as pentane, the alkene will be called as pentene, and the alkyne will be named as pentyne. What happens in functional group is one of the hydrogen is replaced by that functional reactive group. So the alkane name changes to alkyl. For example, if you have methane and if you remove one hydrogen, what we get is methyl. Same thing with the ethane. If we remove one hydrogen, what we get is ethyl and pentyl and so on. So let's take the example of alcohols. These are the compounds that have OH as the functional group. Methyl alcohol, or sometimes we call methanol, will have a methyl group which is CH3 after you remove one hydrogen from methane. And then we substitute that hydrogen with OH, so the formula becomes CH3OH. How about ethyl alcohol? Same thing. From ethane, we get ethyl by removing one hydrogen and we attach OH group. Let's practice how can we get the formula for remaining alcohols. For propanol, it is actually propyl alcohol. So what is the formula for propane? Propane has 3 carbon atoms and that makes the number of hydrogen atoms as 3 times 2 is 6 plus 2 H8. So when we convert that to propyl group, we lose one hydrogen. So we get C3H7. And if you connect OH group to that, that becomes an alcohol. So it will be C3H7OH. How about butanol? Butane is C4H10. So the butyl group will be C4H9. And the butyl alcohol will be C4H9 and hydroxide OH attached to that. Pentanol, what's the formula for pentane? It is C5 and hydrogen will be 2 times 5, 10 plus 2, 12. The pentyl group will be C5H11 after it loses one hydrogen and simply attach that OH that makes it pentyl alcohol or pentanol. Now let's cover one more thing, how to name cycloalkanes. All these are saturated monocyclic hydrocarbons. The only difference between the chain alkanes and cyclic alkanes is you have to add the word cyclo before the name. You are still going to use the same phrase, mom eats peanut butter, so that's methane, ethane, propane and butane, and beyond that we use penta, hexa and so on. So look at this structure. We can clearly see we have 3 carbon atom that goes with peanut and that's why it will be propane. Since it is a ring shaped, we added the word cyclo, so it's cyclopropane. What about this? There are 6 carbon atoms, so that means it is hexa. Since it's an alkane, we put hexane and it's in cyclic form, so we added the term cyclohexane. So guess what? You learned how to name alkanes, alkenes, alkynes and cycloalkanes. I hope you guys enjoyed the video. I will see you again in next video. Until then, bye-bye.